let's do an example problem before we continue on our wayward path here. Here's your circle. By the way, it goes without saying that you will always sketch out the circle there. You should always look for how the book wants you to answer the question. For example, letter A, give circumference, and letter B, give area. And the directions say, children, this is where life is good all over, leave in terms of pi. Okay? If they tell you to leave it in terms of pi, your life just became much easier because rather than multiplying something by 3.14 or the fraction 22/7, you can just put the little pi symbol next to the number. And let me show you what I mean. If I'm supposed to give the circumference of the circle and leave it in terms of pi, the first thing I do is write down my formula for the circumference of a circle, which I gave you last time, Caroline. The circumference of a circle is pi times diameter. Okay. If they tell you you can leave it in terms of pi, you don't have to substitute 3.14 or the fraction in for pi. You can leave the little pi symbol there and say circumference is pi times whatever the diameter here is 12. So your answer, and anytime we leave it in terms of pi, you always put the number in front of the symbol. So the answer is actually 12 pi. And you can leave it as 12 pi rather than changing this to 3.14 and multiplying it all out, or using the fraction and multiplying it all out. If they say leave in terms of pi, you will have a pi symbol in your answer. It's just 12 times pi, 12 pi. Same thing for the area. First thing you do is write down the formula for area. Area equals pi r squared, or pi times radius. So the area equals pi times 6 times 6. And again, you can multiply the two 6's together and get 36, but you can leave the pi symbol there rather than multiplying that all out. If they say leave in terms of pi, that's what this means. And this should be labeled as inches squared, and this is just inches. But again, just because we leave the symbols, people, in real life situations, you need to kind of understand what that number would stand for. For example, 12 pi would be awful close to what? Real number. What whole number? If you had to estimate what 12 pi is, Ashley?
Near
36, because pi is close to 3. So 3 times 12 is 36. Same thing here. 36 pi, it's going to be close to 36 times 3. 108, a little bit more than that, 109, 110, whatever it is. But you have to understand, don't just mindlessly put the symbol there and not understand what it stands for. Because mindlessly is not always a good thing. Yes?
Can you put pi 36, or does it have to be after?
In case I didn't say it before, in math, we always put the symbol afterwards. In reality, does it change the answer? No, but in the acceptable format, you will always see the number in front of the pi. Same thing with x. If x comes in your answer, it always comes after the number. You know, 15x is how we say it. We don't say x15, that just looks goofy. Okay, 15x, 15 pi, 36 pi. Symbols always come after numbers. We call those the coefficients there.
What about dollars?
Huh?
Dollars.
But dollars don't stand for anything. It says what you're talking money. It doesn't. It's nothing. All right, now, taking out your notes, still under circles there. When you have a circle, please know that there are, how many degrees in a circle? 360 degrees. That's an incredibly important thing there. Okay, if you cut a piece of a circle out, okay, this little piece here, we call that a sector. Okay, it's really just like a piece of the pie. I don't want to say pie because then you get confused with the pie we were just talking about. Okay, it's just a slice of the circle. So for example, they might ask you this question here. Oh, I guess I got to give you something else here. And there's the sector, and the other thing they will ask you about is this angle right here. Any angle formed by two radiuses is called a central angle. Okay, if it's formed in a circle with two radiuses, makes an angle, we call that a central angle because it's really in the center of the circle. Because they're going to ask you some questions based on that. For example, I know I've piqued your interest in that. Right, oh wait, no. Here we go, write this down. Find the area of each sector. You got this written down? Find the area of each sector. Let me draw you a couple circles here. This first one here, there's my circle. And in that circle I have the center M. And it makes a central angle of 45 degrees, R and S. And we know that this is 4 centimeters. We're talking a little bit of upper level math here, kids. So, the area of each sector. Well, I've got a second problem here. Let's just make this, change this to the sector. Okay, when I'm talking about the sector, what am I talking about? Somebody help me out here. I already told that. Alex? I'm looking for the area of what?
Of RMS.
Yes, I'm looking for the area of this piece of the circle. That's the area. That is a sector. Now, how in the world am I going to find the area of that sector? Because I don't have a formula that says, here's how to find the area of the sector of the circle. Ooh, I see smoke rising and nothing happening. Spinning our wheels, if you will. Now let me go back to the thing I just told you. You know how many degrees are in a whole circle. I know how many degrees are in the sector of the circle. Mackenzie says, unfortunately subtracting is not really going to get me there. Because then I'd end up with 315 and I don't know what I would do with that. Although I think you're getting close to the thought there. Am I quit a check? Okay, I know that the sector is 45 degrees out of, how many? 360. So the sector is what fraction of the whole circle? That's what this will tell you. How many times 45 going to 360? I don't know.
5 divided by.
Okay, we'll cut them by 5. Just kind of says we'll go 9 over what? 72. Oh, 972 reduces down to 1 over 8, right? 9 goes into that. So the sector is 1/8 of the whole circle. So if I find the area of the whole circle, I just have to divide it by 8 because it's only 1/8 of it. So the area of the circle is pi times radius times radius. Now notice I didn't say leave it in terms of pi, so you actually have to do this here. Area equals pi. What is the radius?
4.
4 times 4. Oh, you know what? The book does say leave it in terms of pi. How about that? Let's do that because I don't want to do that math. Leave in terms of pi. Okay, so I end up with the area equals 16 pi. Okay, but that's the whole circle, children. That's the whole circle. I only want to know what 1/8 of the circle is, so what do you suppose 16 pi
2.
divided by 8 is? Somebody out there said 2. Well, you're close, somebody. What are you missing? 2 pi. Okay, the 8 crosses off with the 16 to give you 2, but you can't forget the pi symbol. Which goes after the number. Thank you for the reminder. Otherwise I may have that. Now, here's the second one. What if I asked you to find the area of this sector? Oh, look at that. And it is 16 centimeters. How do you suppose you're going to find the area of that, Holly?
You divide the area of the circle by
Exactly, because that's half of a circle, obviously. So it's going to be pi times radius, all divided by 2, because it's only half of a circle. And what is the radius there?
8.
Thank you. Pi times 8 times 8 divided by 2. What is 8 times 8?
64.
64 pi divided by 2 is
30.
32 pi. And it is area, so we should have put our label as square units there. This math gets more fun as we do. By the way, what's this thing called? Half of a circle? It's got a special name. It's not a half circle, even though that's what it is. This is the name it is. It's
Half
called
slice.
It's a half moon. Half circle.
it's a semicircle.
A semi-slice.
Semicircle means cut into half, whatever it is. Kendall?
Will there ever be negatives?
Not at this point. Not sure what you mean. And one less problem, just because I know. Write this down. Take a little note here. A lawn sprinkler waters a circular portion of a yard. A lawn sprinkler waters a certain, let's say if I say certain or circular. A circular portion of the yard. Of the yard. The radius of the circular portion is 7 feet. Calculate the area of the yard watered. Calculate to the nearest square foot the area watered. And again, the obviously first thing you're going to do is there's a lot of words there that you need to turn into a nice little sketch. And if you've ever seen yard sprinklers, that's generally how they work. You've got this little sprinkler head and water shoots out in a big circle, watering only a circular. Now they do make other kinds, but that generally speaking is what happens. It shoots water in a big circular pattern. We know that this is a 7-foot radius. So what am I going to do to find area, Kendall? Yes, write down the formula. Formula is
Pi times radius times radius.
pi times radius squared. Area equals,
Pi
now notice I didn't say leave in terms of pi there, but what is the radius?
7 times 7.
Now let me give you a little clue here, children. Okay, remember we said the two acceptable forms of pi are either 3.14, and both of these are what we call approximations, or 22/7. If your radius is some multiple of 7, use this. Actually, the book usually tells you which one to use. But if the radius is some multiple of 7, use 22/7, because you can divide 7 by 7 very easily. In other words, 7 times 7 is 49. And if you multiply 49 times 22/7, the 7 cross cancels with 49. And you end up with 7 times 22, which is 154 feet squared. It's much easier than 3.14 doing all that long multiplication. So if you come up with some, if it's a 7, a 21, a 14, a 28, any multiple of 7, it's always easier to use that fraction for your pi. Ladies and gentlemen, this concludes